Okay, this is the homework that will be due on Monday, October 19th. As you can see, you must write two equations that have the following roots. So we talked about this in class. So you need to give me two equations that if I went through and solved them, it would give me solutions of 2.5 and negative 3. Two equations that do that for each one of these sets of roots. Okay? I'm going to go over a couple of them. So try them on your own, and I'll be back to go over two of them, I believe. Okay? Okay. Um, you're asked to come up with two equations that have these particular roots. How are we going to go about that? Well, in class we've been working backwards to figure it out. So think about if you're given some equation, say for instance, I don't know, x squared plus, let's see, plus 5x plus 6 equals 0. And then you say, oh wow, that can factor, so x plus 3 and x plus 2 equals 0. And then I come and I say, okay, well x plus 3 equals 0, or x plus 2 equals 0. And then I solve and I get x equals negative 3, or x equals negative 2. Now, what we're doing over here, what I'm doing in this, what I want you to do in this problem is actually work backwards. So you have this, and you need to come up with this, right, for these particular roots. All right, so that's what we're going to do here. All right, so I'm going to start off. I'm actually going to maybe I'll actually write it down here. Let's just say I come up with something, or I have, these are the roots I have. Let's just put it that way. X equals negative 5, 6. X equals 1/3. Now, how would I get that x equals negative 5, 6? Well, if you look and think about what I just did in the example. Remember, in the example, we had, I'll just write this, I'm going to write this down again because it's good to look at. Even though it's a different problem, it's good to look at. X squared plus 5x plus 6 equals 0. You end up with x plus 3 times x plus 2 all equals 0. And then you set your factors. So x plus 3 is a factor, set that equal to 0. Or x plus 2 is equal to 0. So x equals negative 3 and x equals negative 2. All right, now we have this part right here. Now, the next part, if you worked backwards, would be this. So how would I get x plus 3 from that? How would I get that from right here? Well, I'd have x plus 5, 6 equals 0. And here I'd have x minus 1/3 equals 0. What I did basically is took this original part here and just subtracted 1/3 on both sides. And then I added 5, 6 on both sides. That's how I get this and this. Okay, now if I keep working backwards, what about this part? Well, I just take what I have here and I write them as factors. So I have x plus 5, 6 times x minus 1/3 is all equal to 0. Okay, so now, really, in reality, this is a legitimate equation. This is a quadratic equation that will give you the solutions that I asked you for, right here. This is a legitimate equation. Okay, now I'm going to erase this part. But a lot of students, they want to see it multiplied out. And it might be easier to get a second equation. Remember, you have to do two equations, not just one. So to get that second one, it might be easier if we multiply this out. So I'm going to multiply this out. So we're going to have x squared, and then minus 1/3 x, and then plus 5, 6x, and 1/3 times, negative 1/3 times 5, 6 would be negative 5/18. All right, and combine our like terms. All right, and again, and don't forget this equals 0. Again, this is actually a legitimate equation. If you gave me that, that's actually the same as this one with the parentheses. But if you stopped right there, that'd be an equation. But if we kept going and combined it, let's just keep going here. And we need to add 1/3, negative 1/3, and 5/6. So what's negative 1/3 plus 5 over 6? We end up with negative 2 over 6 plus 5/6, which equals 3 over 6. So we end up with x squared plus 3 over 6x minus 5/18 equals 0. So that would be, if I want to write something in standard form, an equation that would give me these roots, this could be our first equation. But remember, I asked for 2. So how do we come up with a second one? Well, we talked about that in class. We could take this equation and we could multiply it by any value. It doesn't matter what you multiply it by. So as long as I take this equation and multiply it by anything, I could multiply it by, I'm going to erase some of this other stuff now that I've done here. Okay, you could multiply this entire equation by 2. You could multiply it by 3. You could multiply it by 4. Your resulting equation is going to give you the same solutions. That's something we talked about in class if you were there on Thursday. So I can take this original equation and I'll just multiply it by 2. Now, if you wanted to get rid of these denominators and have all whole numbers, you'd have to multiply by a denominator that all the denominators go into. You have to multiply by a number that all the denominators go into, which it looks like 18. So if you wanted that, let's just say you wanted an equation that had all whole numbers. Fine, we'll multiply it by 18. So we'd end up with 18x squared. And 18 times 3, 6 would give me, these would cancel, so I'd end up with, that'd be plus 9x. And the 18 and the 18 would cancel, so that'd just be minus 5 equals 0. So that could be your second equation. Okay, now let's just say you don't care about there being fractions. Well, you could have multiplied, like I said, you could have multiplied it by 2. If you multiplied it by 2, so this is your second. So we have one equation, we have 2 equations. All right, so let's just say you would multiply the original one by 2. All right, then you'd end up with 2x squared plus x, because 2 times 3, 6 would be just 1, that'd be x. And then 2 times 5/18 would be minus 10/18 equals 0. So this actually could be a third one. Again, and you could multiply this original, you could multiply any of these equations by any number. As long as you multiply every single part on both sides, you are creating an equation with the same solutions. They're all going to have the same solutions, which are negative 5 over 6 and 1/3. So there's your first example. Okay, this one, again, it's a little bit different when you have radicals. If you have radicals, this means that you would have had to use a quadratic formula or some other method. This could not have factored. This problem here, if you look at these roots, they're both rational numbers because they're both fractions. We know they're rational numbers. This tells me this could factor, or the equation that created these roots. Don't even need that. The equation that created these roots could have been factored. I know that because the solutions are rational. Here, not the case, right? So whatever equation created these solutions could not be factored, cannot be factored. Okay, so I'm going to start, and we have x equals 5 plus 2 radical 2. All right, A little different process. You're not really necessarily working backward. You kind of are, but not as much. I'm going to subtract 5 on both sides. I'm going to have x minus 5 equals 2 radical 2. Now, that 2 radical 2 is getting in my way. So how can I get rid of a radical? Well, the opposite of taking the square root is just a square. So I can square both sides. So I'm going to end up with, this side is going to be x minus 5 times x minus 5 equals, now we have on this side 2 radical 2 times 2 radical 2. That gives you, this gives you 4. And radical 2 times radical 2 gives you 2. And 4 times 2 is 8. So we end up with 8 when you do 2 radical 2 times 2 radical 2. That equals 8. All right, I'm going to go ahead and multiply this side out. That's going to give me x squared minus 25, not minus 25, minus 10x plus 25 equals 8. And then I'm going to set it equal 0, subtract 8, subtract 8, and I'm going to end up with x squared minus 10x plus 17, right, equals 0. And that actually will be my equation. And you don't even have to worry. Now, you might think, well, what about the other one? What about x equals 5 minus 2 radical 2? Well, let's try that. Right? If you have your other root, which is x equals 2, or is it 5? What did I say? Okay, 5 minus 2 radical 2. And you notice you have a minus here for our root versus your first one was a plus. So you have a plus and a minus. So you might be thinking, well, am I going to get different equations? No, you're looking for one equation to create them both. And if you go through the process of doing this the same way that we did the first one, you're going to still have x minus 5 equals negative 2 radical 2. What you're going to do still again is square it. Square it. Now, here's the thing. You're going to end up with the same thing on the left that you had over here. So you're still going to have x squared minus 10x plus 17. And on the right, no, I'm sorry, plus it's the same that you had here, not the original. So be careful. 25 equals, now remember, this is negative 2 radical 2 times a negative 2 radical 2. So you have a negative times a negative, which still gives you a positive. So you still end up with the same thing that you had over here. Still going to be 8. Then you're going to have x squared minus 10x plus 17 equals 0. So it's still, either way, with either one, you get the same roots. Now, you might say, well, I don't believe that that's going to give me that solution. Well, we can check it. How am I going to check it? I can go through and solve it and make sure we get that root back. So if I went through and solved it, I'd have, you're not going to factor this, so I'm going to jump right to the quadratic formula. You have x equals negative b, so our a is equal to 1, b is equal to negative 10, and c is equal to 17. So I'm going to have x equals negative b, so the negative of negative 10 is just 10, plus or minus square root of b squared, so you have negative 10 squared, which is 100, minus 4 times 1 times 17, so 4 times 17, all over 2a, which is just going to be 2, and then I'm going to keep going here. You're going to have x equals 10 plus or minus 4 times 17 is 40, 28, 68, so this is going to be 32 all over 2, and then I'm going to break down this 32. That's going to be okay, 32 is, you can break that down into x equals 10 plus or minus. I'm going to break that down into 16 and 2, because 16 is the largest perfect square that goes in there, all over 2. So it's going to be x equals 10 plus or minus 4 radical 2 all over 2. Now, remember, you have your triangle of numbers here, triangle of numbers. If they all are divisible by the same thing, then you can simplify. So you're going to have x equals 5 plus or minus 2 radical 2. And remember, you split up your plus and your minus. You have x equals 5 plus radical 2 and minus radical 2, 2 radical 2, which is the same as that. So that means that this is an equation that works right here. So here is one equation. Now, in order to get a second one, you need to multiply this by some value. Multiply this by some value. It doesn't matter what you multiply by as long as you do it on both sides and you do everything. So I can multiply this by 1/2. I can multiply it by 5, by 100. Let's just multiply it by 2. That'd be nice and easy. So I'm going to multiply everything in here by 2 to get my second equation. So I'll just put it on this side. Multiply everything by 2. So my second equation will look like 2x squared minus 20x plus 34 is equal to 0. That is another equation that will give me the same solution. Alright, there you go. And you should be able to come up with multiple equations because all you have to do is multiply these equations by a number and that's what you'll get. Alright, if you see any mistakes, let me know. If you have any questions, let me know.